use just a raw Cartesian product because that's terrible. That just combines every row from table 1 with every row in table 2, and that's usually not what we want. We want a combination of two tables where the rows that are being combined have matching values. And those matching values are in this predicate, defined within that predicate. So I think those three are probably enough to know to generate like 90% of all relational algebra statements that translate to the computer what the human intent is. And so if I were to ask you, why would Dalton walk in here and say, show me every possible combination of student and advisor name pairs on this campus? I don't know why he would ask that, but this is the statement that will mathematically do it for him. I'm going to grab every name from the student table. I'm going to grab every name from the instructor table. And by the way, there's like, this really should be a sigma instructor and sigma student, right? But instead of just drawing a sigma with no predicate, I'm just saying, okay, project out of this table here, because that's really the parameter that those parentheses take. So just grab the name columns out of these things and combine every student name with every instructor name. Well, that doesn't accurately describe the advisor-advisee relationship. And that's why in your database schemas, which you should probably take out about now, you have that advisor table that matches instructor IDs with student IDs, so that there's only one instructor attached to every student on campus. Is probably the traditional way of doing it, although, you know, that database schema will also allow the way Bemidji State does it. I think most of you have 2 or 3 advisors, one in your department, one in trio office or something, but there's a sort of team thing going on with advisors lately. And so we could put 3 sets of your ID with 3 other IDs, 3 separate rows in that advisor table. It would still work. We would just pull out a table with well, actually, show me all student names and their advisor IDs. So that would be a good one to put up next, is a particular student's name and ID. But okay, let me put a pin in that one. So show me all student names and their advisor IDs. Just to keep things simple, let's just assume that there's only going to be one advisor per student. That way the picture in my mind stays pretty. And so does it make sense that we're doing this here? I want to take all the records in student and match them up with all of the records in advisor, except I'm only going to keep those combined rows where the ID from the student table is exactly equal to the value S_ID in the advisor table. Those columns do not have the same name, but they actually mean the same thing. The S_ID value actually came from the student table to begin with. That's why there's a line connecting those two fields together in your schema diagram. And I think the arrow even shows the direction that value followed. I think the arrow head is on the side of the advisor table. Is that right, Beta? Can you confirm that for me? Yes. Okay. All right. And so yeah, this is an improvement over just raw Cartesian product, in that it doesn't join every row with every row. It joins every row with every other row that has matching values on the columns defined, the relationship defined in that predicate. So this big massive table gets joined together, and like you know, there's probably 4 columns in the student table. There's another 2 columns in the advisor table. And that's 6 columns of information. Do we want to see 6 columns of information? That's not what the user asked for, right? They just want to see student names and advisor IDs. And so that's why once we have this combined table, we say filter out all the columns except for name and instructor IDs. That's basically what projection is doing, right? Then again, I mean, that's probably what that's what the user asked for maybe, but then you show them the result of what they asked for, and they say, oh, no, I didn't mean that at all. This is not as useful to me as I thought it would be. I want student names and their advisors' names, because it turns out I can't recognize all these IDs. And so we can do that. We did that by the end of class last time, right? It's just we realized the instructor names are not in either of these tables that we joined together, but these tables are still essential because it defines the student advisor-advisee relationship by at least matching a student's information up with an advisor's and instructor's ID, because we have an I_ID in advisor, so there is a key that came from the instructor table. But if we need more information from the instructor table, we're going to have to bring that instructor table into this statement, right? So this is already one monster table composed of 2 base tables, and we're just going to bring in a third. Out of all of these remaining rows in this table, I want to connect them to all of the rows in the instructor table, where the value I_ID in the advisor table is equal to the ID column in the instructor table. Does that make sense? Hopefully it makes more sense if you have a schema diagram out in front of you. But if you want student names and advisor names and none of the other columns, you don't need to know the advisor's salary, you don't need to know the student's, GPA or whatever that 4th column is in the student table. Now that parentheses are multiplying, I highlight some parentheses in red just so you can see where the outer one begins and ends, but I'm going to take student and advisor and join them on, like I said in class last time, I really should have said s.id, because now we have 2 tables with the field name ID in it, and we should really say student.id and instructor.id. And I just usually shorten that to first letters until I have 2 tables in my expression with the same first letter. But I guess I'm hiding behind the fact here that if I'm just considering these 2 tables, then ID comes from this table and I_ID comes from that table. And that works, but technically, the computer will pretend not to understand that. So I probably have to follow different rules for the computer than I can with you guys. This make sense to you, Dalton? Do you have your database schema with you? If you've lost yours, you can always download a new copy from D2L and reprint it. It feels like we're going to use this in class a lot. Actually, we may be reaching the middle point of use of this and stop using it in a few weeks. Because, I mean, we did all this stuff last week and Monday, right? I want to do more of these today. And you might notice that these are starting from simple things and then getting, more and more detailed, more and more complicated, maybe. Let me start with something simple. from the stuff that you've seen so far today, Dalton, if I were to ask you on the next homework to translate this human intent into something that a relational algebra system could understand, using probably mostly these symbols here. There are other symbols that we could use that you can see in the online videos of this class that are just popping up every other day. This isn't even a hybrid class. What's going on? Do you have any thoughts on how this would work? Otherwise, I can just pick on someone else. Wave me off if you need to.
Would it just be like
Yeah.
course title or something like that?
Yeah. I mean, definitely the source of the data is probably the courses table.
Yeah.
And I mean, I'm not necessarily using the correct name for the column, so you're right. We're probably looking for the title column for the table. But yeah, what is the get operator for data from a table, Aiden? So we want to use that sigma character, that selection operator. And so select from courses. Course is the actual name of the table. And that's going to grab all of the data from the course table, all of the rows. And that's not what Dalton wants. Dalton only wants the titles of all of those courses. And so what's the operator that selects simply column names, Vega?
Capital Pi.
The projection operator, capital Pi. And so we're saying grab everything. Oh, you know, names of all CS courses. There is something that I can add here where department name is equal to CS. We're not exactly sure how they store what the value is in this database, and so we can invent literal values if we need to, as long as they make sense. You could use comp sci. You probably wouldn't want to use bio or chem, or music, but something like CS, that seems like maybe that's how the department name would be named. So, okay, this grabs only the rows from the course table that are CS classes. And then we're going to put that result in another parameter set of parentheses where, like Veda said, like Veda said, we are going to use capital Pi projection. And what is the predicate we want to put for projection? Title. That's what the schema says, right? The humans said name because that made sense to them, but we know, the database operators, that we have to ask for the title column. That makes sense to you, Dalton? All right, well, continuing around the room. Ooh. What courses do you need to take on this campus before you can take this database class? What tables do you suppose would be required for this, and do they contain the data that you need to answer this question? What do you think, Laura?
You need the prereq table,
What are the fields in the prereq table?
course ID and prereq ID.
Those both sound like course IDs. Do you think you can get the course IDs that are prerequisites of all CS 3507 classes out of that table? Are you saying that I only need one table to answer this question?
Probably the course of the class that you need the prereqs.
What data is in the course table that you need for this question?
Pardon?
Course ID,
I mean, I think you have the ID of the prerequisite course and the ID of the course itself in that prerequisites table, right? And apparently this user request isn't asking for anything else. I bet we can just do all of this just with one table. So let's grab everything out of the prerequisite table where the course ID, is that the name?
the field in the table.
Is it course underscore ID? Is it CRS underscore ID?
Course underscore ID.
Course underscore ID, okay. So just to match that document there, if I want to grab stuff out of the prerequisite table, is it called prereq? P-R-E-R-E-Q, is that the name? All right.
Underscore
So-
ID.
Grab from prereq where course ID equals CS 3507. They gave us a literal, so we might as well use it. And I mean, on this campus, you probably know that you have to have passed a CS 2322, for example, before you can take CS 3507. And so probably somewhere in that prereq table, there's a row. I'll just draw it up here. I don't know what else is in this prereq table, but I bet that one of those rows is going to be, so prereq is the title. I suppose I should probably have column names, and so, I don't know, let's say prereq ID and then course ID. Is that the order of the columns in, or is it, it's flipped? Yeah, well, too late. So I actually like this arrangement because, you know, I can put CS 3507 here and it just satisfies something deep inside me to see that the course that you need to take first actually comes before the other one. And you know, even if the order were changed, it doesn't matter because we're telling that selection statement to grab any row where the value of course ID, whether it's the first column or the second column, is equal to CS 3507. But it grabs the entire row. And I don't need to see CS 3507 printed multiple times in this list. What this person is asking for is a list of all the course IDs that they have to take before they can take CS 3507. And so they only want one column out of all of these. Which column is that they want?
Prereq.
The prereq ID column. How do I do that, Mr. Kapiski?
Projection.
And what is the predicate?
Prereq ID.
Yeah. That makes sense? Hey, the slideshow agrees with you, Mr. Kapiski. Is this easy? Can anyone do this?
Yeah.
All right then, Mr. Ogren. It turns out that I like course names, not course IDs. So I still want a single column answer. But I want the names of all these courses that I have to take before I can take databases class.
Okay.
And the thing is, I need to know the prerequisite relationship but the prerequisite relationship table only tells me IDs. How can I connect the IDs that I care about to their names, which are stored in some other table in the database?
Well, we start off by doing what we did before by selecting the course IDs from requisite, just we'll need that. And then,
We want to select all of the rows from the prerequisite table that have a course ID value of CS 3507? Yep. Yeah, what's your next step?
then,
And I mean, there are multiple ways to go. We could filter out just that column and then join that to something else, or we could join something else to that inner table and then filter stuff out at the end. And I think that's probably what people tend to do, but I mean, I don't want to tell you that you have to go this way that I'm shoving you here by erasing stuff on the board. You can tell me to rewrite stuff if you want, but what would you do next?
I mean,
So right now, you've got a list, two column rows, where the value in the second column is always CS 3507. And one row says CS 2322, one row says CS 2321, one row says 1309, CS 1309.
I mean, we also gotta probably just select stuff from the course table. We probably select,
What's the stuff that you care about in the course table?
well, we need the course name. So
Yeah,
the
okay.
title.
So I guess we do need to add how do I join another table to this table's results?
Was it the U or is it?
Not the U,
Was it the X?
the X.
Yes.
Yep. The U is only if I'm adding on to a column, making it longer. It's a vertical concatenation, but what we want is horizontal concatenation. I have CS 2322. I also want to add a column with the title of CS 2322. Okay. So, yeah, we're going to grab everything from the prereq table according to that one course name, and maybe I need to give myself a little bit more room. And I also want to grab everything from the course table. Maybe no prerequisite, no predicate for that. But I want to say, what value do I have in common between the course table and the prereq table?
IDs?
Is that their name?
Probably not.
Oh, dang it, you don't have a,
Well, I do, I have it in front of me.
Oh, yeah, okay. So what is the ID column in the course table?
Just course ID?
Course ID, right? Course
Yeah.
underscore ID?
Yes.
I mean, you gotta tell me what to type, otherwise this statement is gonna fail, right?
Yeah.
So, I'm just going to do pre-pending just in case, but course.course ID, course underscore ID, has to be equal to prereq dot course underscore ID, right?
Yes.
The name didn't even change. We could use a natural join on this and it would work. Put a bow tie in there, and then we don't even need to put a predicate in there. Okay, so everything from every row in the course table will match up with all of the CS 3507 rows from the prereq table, but only they'll only combine if their course ID is the same in both of those tables, which means C dot course ID is equal to P dot course ID. Actually, which means the only row from the course table that will connect with all of these rows that I've retrieved from the prereq table will be the row describing the CS 3507 class, right? And so the only title that I'll have access to in this joined structure is Intro to Databases. And that's not really what I want, is it?
Yeah,
Do you see what I'm saying?
yes.
So let me illustrate the structure that we're getting from this join here. Is we're getting the 2 rows from the prereq table, and I'm going to write it correctly according to your document there instead of this thing here, because I think I heard that course ID comes first in your design document, followed by prereq ID. And then when we did that Cartesian product operator there, we're adding to all of that everything from the course table. So that's course underscore ID, and then you guys are going to have to remind me what comes next. Probably title, right? Title, and what else is in the course ID table?
Department name and credits.
Thank you. Depth underscore name and credits. And so the result of that Cartesian join is going to be a table with this design that doesn't exist. It's just, a virtual table that's created as a result of that. But all of the values there, let's say that I had, so we only grabbed the course, the values from prereq where the course ID was CS3507. And I think according to the website, there's really only one prerequisite to CS3507, and that's CS2322. But just for variety, I'm going to pretend that CS2321 is also listed as a prerequisite, and also CS13. I'm going to put the modern number for it, 1310 rather than 1309, are also prerequisites for CS3507. So all 3 of these rows got returned, although I think in real life only the first row would have been returned. So that was what came back from that second selection statement. Grab from the prereq table everything with a course ID value of CS3507. All right? And now what we did is we say, okay, and join onto this table everything from the course table, where the value in course ID is the same as the value in course ID. So this is prereq.course ID, and this will be the course ID value that comes from the course table. Right? Well, if we're joining rows from the course table that have the same value as this, then I bet it's going to be CS3507, that it has to be that because it has to match. And then the title is Intro to Databases. And department name is CS, and credits is 3.0. And for this row, the only row that matches is CS3507, Intro to DB, CS 3.0, CS, basically this. Yeah, I need to throw in another copy, whatever. And that's probably not what the user asked for. What should we have put in the predicate to that Cartesian product? You have an idea, Sam?
Well, they want to print out what the names of the prerequisite courses are.
Yes. And right now, we don't have the names of the prerequisite courses.
No.
How can we make this the names of the prerequisite courses?
Prereq ID?
C.course ID is equal to P.prereq ID. Yeah. You had the right idea. It's just prereq ID only exists in the prereq table. So.
Yeah.
Do you see how this changes that result?
Yeah.
Because now we're not connecting to the P.course ID column. We're connecting to the P.prereq ID column. And in that case, this row is not CS3507. It's CS2322. CS 4.0, 4 credits for that one, lab. And it is a CS2. And we're connecting to that row, and the only row in the courses table that has the same value as prereq ID in it, its data is CS2321. Its title is CS1, also CS department, also 4 credits. And the row that comes from the courses table that matches this value is its course ID has to be the same, CS1310, because that's what we said the predicate should be. And its title is problem solving and computation, right? I'm just going to shorten it PS and C. Also a CS course, 3 credits, and all this comes from the prereq table. Does that make sense? We change one little value in one tiny little place in that relational algebra statement, and our entire result changes. Of course, you guys are used to this happening just from writing programs in CS1 and CS2. You change one detail and all of your results are liable to change. But yeah, let's, is that what the database thought would happen? I think I've put down my clicker, it's right over here. Oh, we don't want all of these columns. All the user wanted was course names, and so yeah, we should probably filter out everything except the title. But yeah, otherwise, inside here, I guess the order in which we do things doesn't really matter, just like addition. We grab all of the 3507 rows out of the prereq table and join them to all of the rows in the course table where course ID is equal to prereq ID. And if I wanted to be specific, if the computer forced me to be specific, I should probably say p.prereq ID is equal to c.course ID. Since prereq also has a course ID in it, we're guaranteeing that the computer doesn't misunderstand us for some reason. Does that make sense? It turns out, since we have data scattered throughout the system in multiple tables like this, when we want to get just, simple stuff done like this, all I want is a column of names, come on. But these names depend on the prerequisite relationship. It forces me to join 2, sometimes 3, sometimes more tables together just to get all of the strings from their different locations together into one result. You have to ask yourself, where is the data that I want to print? Where is that located? Where is all the data that needs to be in a single table? Usually it's not all in a single table. Sometimes you get lucky. And also, what are the glue values that I can use between these tables? And what that database schema shows you is exactly those column names, those columns between tables that mean the same thing, even if they have different names. And that's what I find so useful about that diagram. So all of that just to show course names of all prerequisites of course ID. Does that seem overcomplicated to anyone? I think this is as simple as we can make it. For some reason, I'm starting the next slide with the same intent or the same question, and so I assume that, I guess I'm just building this piece by piece, but this should be a repetition. What the heck? What is this doing? I am creating another copy of the course table here. I'm going to name it C2. And so I'm grabbing all of the rows from the course table. I'd rather grab all of the rows from from the prereq table. Oh! I'm not just grabbing computer science rows now. Maybe I wasn't before. This is a little bit different from the last one, right? Just to refresh my memory, let me go back to the last one. Yeah, the last one, I was just grabbing the rows that had CS3507 in the course ID field there. I just want to show you with this other example that we can get to the same result in different ways, but kind of what you start with might depend on might change how you have to build this command in order for it to give you your result. What if we were to just grab one row out of the course table, the CS3507 row, and we want to join that to whatever we can in the prereq table? So that's going to be that Cartesian product. I want to match, since the only value that I have at this point is the CS3507 course, then I'm going to match in the prereq table to course ID instead of prereq ID, right? That's one significant change from last time. What is this joined table going to give me? Well, so far it's going to give me the original thing that I had there before, but just one row. Oh, well, I guess if we're still assuming that there are three prerequisites to CS3507, then it would give me 3 rows, but I'm basically going to have 3 copies of the CS3507 row joined to each one of the prereq rows from the prereq table. Right? And that's not going to give me the course names of the prereqs because right now I have details for CS3507 repeated 3 times. The picture that I showed you before, that I drew out on the board before. And so that's why in this case, if our brain works in such a way that it's just easiest for us to start with this, because that's what we focused on in that statement, then this doesn't get us all the way there. We need to say, oh, I still need the names of the prerequisite courses from the course table. And so I can take this table, which is no longer the course table, and say, okay, join this thing to the course table. And since I'm already referring to the course table in this statement, I'm just going to give it a different name. And that's why I say, join to a copy of the course table named C2. And this time, I want the prereq ID value from this table. So CS 2321, 2322, and 1310 in the example that I have. I want those to be the same. I only want to match to those rows in this second copy of the course table. And so now I'm going to add another 4 rows. Well, actually, at this point, all of this stuff is coming from the C2 table because the part that I didn't want to redraw, I am now redrawing. Course ID and title and depth name and credits. These first 3 rows were all CS3507. The DB class. So before I added that second line, that second Cartesian product, I was showing these 4 columns and these 2 columns. And by creating a second copy of the course table and joining them on only where C2.courseID is equal to P.prereqid, I ended up also inserting these 4 columns into the table. And probably they were appended at the end. Again, order doesn't really matter. Order of columns, order of rows. We end up with the same information either way. What I'm saying is, this statement returns the same information as the prior statement, especially after I add the projection operator on it that says, only show me the title column from the C2 table that got joined in, and that is going to show me, according to my whiteboard now that it's updated, that's going to show me CS2 and CS1 and problem solving and computation, right? The C2 dot title column. That makes sense, Preston? I'm hearing a whole bunch of silence here, but all of this stuff comes from the C2 table. All of this stuff came from the course table. And really, C2 is just another name for the course table. The path that I took, I ended up having to join to it twice. And then, of course, all of this stuff came from the prereq table. Is this less efficient than our first one? Yeah, probably. There's more data, more columns. Remember when I said that your database system is going to try out several approaches to see which one is going to be the most efficient? This is one example of what it might do to solve the same problem as, oh, I could start at this table first and then join, or I could start at this table first and join, and end up with the same result either way, and then it's just going to figure out the mathematics and probably count number of rows and count number of columns that it had to go through in order to get to that single column result. And it would probably say, you know what, I should probably execute the first relational algebra statement rather than the second. And these are tiny little results, and so the time that it spent doing the analysis is probably more than the time that it would save from just going with the first one. But typically, when your database is analyzing something that it's going to do, it's thinking about throwing together tables with 1,000 rows each in them, and that's when combining 1,000 rows with another 1,000 rows and then filtering out anything that doesn't match actually can save you some time. Will save you some time. In fact, even in this case, I'm just looking at the results and saying, oh, that's very tiny. But actually, it depends on how many rows are in the courses table and how many rows are in the prereqs table. There's probably a couple of hundred rows in the courses table, and there's probably 300 or 500 rows in the prereq table. Is there a third way we could get to that result? I feel like, oh, does this get me to the same result? What's going on here? Oh, actually it's just, is this what we did before? I think this is what we did before. This is an alternate to what was on the bottom of the last slide. All right. So yeah, I think pretty much any time you can save a join out of your statement, that's going to be more efficient. But I would accept either one of these if I were asking you on a midterm or something. Give me a relational algebra statement that shows the course names of all prerequisites of course ID 3507 according to your database schema. And by the way, a question like that will probably be on the midterm. Oh my goodness. I wasted all this time just talking about basically one intent. Can I show you another one? Actually, this uses the results of that previous one. Because probably when you're looking at a list of prerequisites and courses, it's going to be a list of prerequisite names and then the name of the course that they're prerequisites for. And we have all of that information in this joined table here, which we didn't in the more efficient version. We only had the names of the prereqs, but not CS30, not intro to DB, or we only had intro to DB and not the prereq tables. Asking this question, which feels, I mean, the only change is I'm just adding the title of the course that that these other titles are prereqs for, this forces me to join three tables together. This forces me to do this, because that table there on the whiteboard is the only table that has not only the title of the course that we're getting the prereqs for, but also the titles of the prereq courses. So I guess what I'm saying is, if the person wants to see the course names of all prerequisites to a course ID CS 3507, as well as the title of course ID CS 3507, a 2-column result, right? Then that's going to be this statement with this projection operator, and it'll say C2.title and also, comma, course.title. So we can grab, we can grab the title column out of the course portion of that monster joined table on the whiteboard there. Right? Is that what this says? I think so. Does that make sense? All right, I guess I'm out of time, but that one, if you had to build that one raw without the previous commands there, it would have taken us, a little bit of time here. I'm going to start on Friday with just more intents, and I'm going to ask you guys to build me the relational algebra statements for them so that you can be ready for the coming midterm. All right? So bring your database schemas with you next time. We'll definitely be using them. Otherwise, I will see you guys on Friday. Thanks for showing up today.